Q8096. What is the basic operational sequence for reducing the power output of an engine equipped with a constant speed propeller? A. Reduce the RPM, then the manifold pressure. B. Reduce the manifold pressure, then retard the throttle to obtain the correct RPM. C. Reduce the manifold pressure, then the RPM. The correct answer is C. When reducing the power of an engine fitted with a constant speed propeller, it is crucial to retard the throttle first in order to lower the manifold pressure before lowering the RPM using the propeller pitch control. When performed incorrectly, the combination of low RPM and high manifold pressure can result in cylinder pressures high enough to badly harm an engine. Q8097. Which statement pertaining to fuel-air ratios is true? The mixture ratio which gives the best power is A. Richer than the mixture ratio which gives maximum economy. B. A rich mixture is faster burning than a normal mixture. C. The mixture ratio which gives maximum economy may also be designated as best power mixture. The correct answer is A. A richer, more fuel-to-air, fuel-air mixture is utilized for an engine to create its optimum power as compared to a mixture that produces the most efficiency. The ideal fuel ratio for power generation is roughly 12:1, 12 parts air to 1 part fuel, whereas the ideal fuel ratio for economy is at 16:1. Q8098. Backfiring through the carburetor generally results from the use of A. An excessively lean mixture. B. Excessively atomized fuel. C. An excessively rich mixture. The correct answer is A. Backfiring through the carburetor refers to the combustion of fuel and air mixture occurring in the carburetor or intake manifold, rather than in the combustion chamber. This can cause loud popping or banging sounds and potential damage to the carburetor or intake system. When the fuel-air mixture is excessively lean, it means that there is not enough fuel compared to the available air. This lean mixture can lead to incomplete combustion and unburned fuel reaching the carburetor or intake manifold. When the unburned fuel encounters a spark or hot surface, it can ignite and cause backfiring through the carburetor. An excessively lean mixture provides insufficient fuel for the combustion process. Without enough fuel, the air-to-fuel ratio becomes imbalanced, and the combustion becomes unstable, leading to backfires. Q8099. Which of these conditions will cause an engine to have an increased tendency to detonate? A. Late ignition timing. B. High manifold pressure or high intake air temperature. C. Late ignition timing and an overheated engine. The correct answer is B. Detonation is an abnormal combustion phenomenon that occurs when the air-fuel mixture in the combustion chamber ignites spontaneously or prematurely, causing a rapid and uncontrolled burning of the remaining mixture. It can lead to engine damage and a loss of power. Q8100. When will small induction system air leaks have the most noticeable effect on engine operation? A. At high RPM. B. At maximum continuous and takeoff power settings. C. At low RPM. The correct answer is C. At low RPM, the engine requires a precise and consistent air-fuel mixture for smooth combustion. Any additional air entering the engine through an air leak can result in a leaner mixture, causing a disruption in the combustion process. This can lead to rough idle, hesitation, misfires, and overall poor engine performance at low RPM. At higher power settings such as maximum continuous and takeoff power settings, the engine is operating at higher RPM and demands a larger quantity of air and fuel for combustion. In these conditions, the additional air entering through small induction system air leaks may have a lesser relative impact on the overall air-fuel mixture. The increased airflow at higher RPM can compensate for the small leaks to some extent, resulting in a less noticeable effect on engine operation compared to low RPM.